In this video, I'm going to show you how to create depth first search using post order in a binary search tree. All right. If you have not watched the previous lecture when I created the depth first search in order, I highly recommend that you watch that, because what I did was I set up a breakpoint at the beginning of the function and stepped through the code one by one. So this way we were able to look and to watch the call stack and see how the code runs and have a better understanding of how the recursion is also running when performing this depth first search. All right. And in addition to that, I also mentioned that the only difference between the depth first search for the pre-order, in order, and post order was one line. And that was this line right here. It was simply just the positioning of where this was located. So as you can see in the pre-order, it's positioned at the very beginning of the traverse function. In the in order, it's positioned right dab in the middle between these two traversals. And, well, as you can probably already guess, for this final one we have, I'm going to copy and paste here, depth first search post order. We remove this here from the middle and paste it at the very end. And this right here, my friends, gives us the solution of depth first search post order. All right, so this completely changes the output of what we get here. And what we should get here is this. We'll get an array with 3, 9, 7, 12, and then 10. So if I go ahead and test this out, I'm going to do console log tree depth first search post order. Expand the console, and we should get this here. So I'm going to run this code, and indeed we get 3, 9, 7, 12, and 10. So I'm not going to run through the whole entire block of code like I did in the previous video. So again, I recommend you do, but let me tell you, so the post order, the way it works is that we obviously start at the root node, right at the very at 10, and it's going to traverse all the way to the left and to the left until it reaches the very end, and we run into the bottom left furthest possible route. So that would be 3. So at this point, what happens is that we end up pushing the result of the children before we push in the parent itself. So in this case, we reach the very end, furthest left, which is here. So we're gonna push in the value 3, and then we go up here, but this 7 still has a child to the right. So we just move to the right and then push the value of 9, and then we go back to the 7, and then at that point then we finally push in the value 7. But then we go back up here to 10, but we don't push in 10 yet, because 10, yes, it has its children here, which we pushed in the value, but it has another child to the right. It has a right child, so we have to go traverse to the right over here. And well, 12 doesn't have any children, so we can push this into the result. And then finally it goes back, and 10 realizes that it output it's all of its children. So then it can finally, at the very end, hence the name post order, push in 10 into the result. Okay, so we always push the children before the parent. So the root node is always the last element to be pushed in. And as I said, the only difference is changing the position of this line of code. So for the post order, all we have to do is place it at the very end, okay, right after the 2 traversals. And that is your depth first search post order.